Okay, 22.5, solving nonlinear systems. So we haven't done any systems with nonlinear, so we're mixing quadratics and different types of functions here. But we've done systems before, and methods that we use with linear systems we can apply here, but graphing is still an option, and we're going to look at that. So it talks about graphically how to do it by hand. Obviously, we can use the calculator on this. So we're going to do this one graphically. First thing we want to do, I'm going to look at this one, and I'm going to look at this as the vertex form of a quadratic. So my vertex, when it's with the x, it's not what you think. So I go to the left 2 and up 8. So left 2, up 8, and right there is my vertex. Now my slope, quote unquote, is a -2. So what that means is I'm going to go down 2 into the right one, but also down 2 into the left one. I went over too far. Sorry about that. Let me erase that first mark. Down 2 into the right one, down 2 into the left one. Okay, and then if I wanted other points, okay, so then we're going to get a couple more points here. And you can go to the table on your calculator, but I know I'm going to be at 0, 0, and also -4, 0. So that gives me 5 points here. So I'm going to connect those, draw my parabola. Then I'm going to graph my line. So I'm going to do my line in green, 4x plus 16. So I start at 16. Okay, so here's an issue right now. 16 is not on my graph. Okay, so I've got to think of points that would work in terms of other values here. So I'm really shifted over to the negative side. So I'm going to try like -2. If I plug a -2 in here, that's 4 times -2 plus 16, which is 8. So at -2, I have 8. Okay, I can try -4. 4 times -4 plus 16, that's 0. Okay, so at -4, I have 0, ironically enough. So then I draw my line here. So where does it intersect? It intersects here and here. So I have the point -4, 0, and I have the point -2 and 8. So those are my 2 points of intersection. Okay, now what I'm going to do in the second example here is I'm not going to graph it by hand. Instead, what I'm going to do is I'm going to put this in for y1. I'm going to put this in for y2. So I'm going to type those in on the calculator. Got x plus 1, quantity squared minus 9, and then I have 6x minus 12. Then I'm going to graph it. Now remember, what I'm looking for here is the point of intersection. So make sure on your graph itself you can see where they intersect. Sometimes it's kind of hard to see. So what I'm going to do in this case, because if you look at it on the calculator in standard window, they look really, really close. The parabola is doing this, and then the line is like kind of butted up against this, and I can't see if it intersects once or twice. So what I'm going to do is I'm going to change my window and make it a little bit closer. So I'm going to say my x min is 0. I'm going to say my x max is 5. So let's go to window, x min is 0, x max is 5, then graph. And what this does, it closes up the window a little bit to see. Now in this case, I can see it looks like it just hits it at one point here. So I'm going to go to second, trace, number 5, intersect, and then press enter 3 times. And I get the point, 2, 0, 2, 0. Now, what I'm going to do is I'm going to check and make sure that works. So I'm going to plug 2 in. What's 2 times 6? 12. 12 minus 12 is 0. Do it for the other one. 2 plus 1 is 3. 3 squared is 9. 9 minus 9 is 0. So that works. So this case, there's only one point of intersection, 2, 0. All right, this one says solve algebraically. Okay, so what does that mean? What that means is we're just going to set these equal. So we're going to have, I'm going to put this for that y. So I have 3x minus 3 equals 2x squared plus 9x plus 5. Now, again, you could do this on the calculator, and you could do this one for y1, and you could do this one for y2 if you wanted to. But I'm actually going to do this using algebra, just to review solving here. So the first thing I want to do is I want to get everything equal to 0. So I'm going to subtract 3x, and I'm going to add 3. So they're gone. So I have 0 equals 2x squared plus 6x plus 8. And I'm going to do this when I'm going to try factoring. So I'm going to take out my GCF, which is 2. Okay. Factors of 4 that add to give me 3. Or there are no factors of 4 that add to give me 3. So I'm going to review my discriminant. So let's review discriminant. Remember, discriminant is what was under the square root, the b squared minus 4ac. And that told us how many solutions there were. So in this case, a is 1, b is 3, and c is 4. So I get 3 squared minus 4 times 1 times 4. So if I do that, I get 9 minus 16 square root of negative 7, okay? Remember we said you can't take the square root of a negative. That's an irrational, or not an irrational, an imaginary number. And you'll deal with those in Algebra 2, but it's not a real solution. So that does mean this one has no solutions. So you can still have our special cases. They don't have to intersect necessarily. So here, the reason I circled this, I want you to make sure you note. You can refer to the book here to help you in terms of finding the intersection. You can do this on your calculator, which we did previously. We've got one more problem here we're going to look at. A billboard painter is using a pulley system to hoist a can of paint at a rate of ½ hour per second. It's given by this function. 5 seconds after he starts raising the can of paint, his partner accidentally kicks a paintbrush off the scaffolding, which falls to the ground. The height of the falling paintbrush is given by this function. When does the brush pass the paint can? So all we're doing is we're setting those two, trying to find where they're equal. So I'm going to put this one for y1. I'm going to put this one for y2. And in this case, I'm going to use the calculator again because you got decimals. Anytime you have a decimal, it's just kind of easier to do the calculator. So I'm going to go back to Zoom 6 standard. So there's my line. And then there's my parabola. So it intersects twice. So I'm going to do second trace number 5. Enter 3 times. So the first answer I get is T is 2.58 rounded. Okay. So, and then I've got this other answer. Okay, so I'm going to go ahead, second trace, number 5, enter twice, but then use my right arrow key to get my cursor over near that other intersection point. And then press enter. And here I get T is 7.32. Okay, now let's talk about this. The height of the can of paint. Okay, so a billboard painter is using a pulley system to hoist a can of paint. So the paint can is what? It's going up, and it's going up at this linear rate. The height of the can of paint as a function of time is given. 5 seconds after he starts raising the can of paint, his partner accidentally kicks a paintbrush off the scaffolding. Okay, 5 seconds after. The height of the falling paintbrush can be represented given. When does the brush pass the paint can? Okay, so at this point, we've not reached the 5 seconds yet. So we're still hoisting the paint can up. So then it actually passes it after that 5 seconds at this time, okay? So that means a total time of 7.32 seconds was in the air, but it was 5 seconds after, so I subtract that, so it would be 2.32 seconds after he'd been hoisting the paint can up that they pass. So this one's irrelevant because that was before the 5 seconds of hoisting the paint can up. So again, these word problems sometimes can be tricky, but you got to think in context. So that's this lesson.